Hello guys, welcome to our new video, and in this video we are continuing our try data structure coding. Okay, so in my previous video, as you know, we had explained about how we use try data structure, how we insert, search and delete, and I hope you guys understand. If you did not watch my video, please check it out on my YouTube channel and watch before implementing the code. Okay, so in this video we will do some coding, how we gonna implement the try data structure in C++. As you know, we already have the Ubuntu Linux, and I'm just gonna show you the code. I just write it the code so that we can save our time, otherwise the video will be so long. Okay, but I will explain you how we're gonna use this and how we implement. Okay, so as you know, this is our C++ code. As you know how we're gonna make a class. I will not go deep into, but still I will show you how you're gonna implement. Okay, so we have a try node, which is a class, and then it has a pointer which represent the children, which is 26. Definitely we have 26 characters in English, so that's why we use 26. And then we have this boolean variable, which is and, which I used in my previous video. As you know, we use tick and cross, and that shows that string is valid or not. So in programming, definitely we use the boolean, which says true means string is valid, or false means it's not valid. Okay, and then you can see try node, which is we will make a new node, and we just basically traverse the for loop on the every children, so that it can point null ptr. Otherwise it will store some garbage value, so we don't need any error in our programming. So we just need to declare every children as a null ptr right now. Okay, and then we have a class which is try, which will has a private variable, which is try node, which represent the root. And then we will make a uh, new node of the root. Okay, we have a pointer which points to the root of the try tree. Okay, and then we have a insert function, which is quite, you can see it's quite difficult for you guys, but I will show you how we're gonna implement this. Okay, so let's suppose we already have one node, which is a root node. Okay, and then we have a children, which is pointing to null ptr. So right now we don't have anything in here. Okay, so we're gonna do is how we're gonna insert in our try node. Okay, let's suppose we have a variable which is cat, and we want to insert in cat in our. So first we're gonna go to this function insert, which has string as a constant, and then it will make a new node, and which will point to the root. Okay, which is this one, and then it will traverse each. So we have cat, which has three characters, which starts with C. Okay, so what is int index C minus A? As you know, the every characters has their ASCII value. So A represent the 97, because the small lowercase abcd starts from 96, 97, and the uppercase starts with 65. These are the ASCII values of these. Okay, so in this case we have a C, the character C minus A. So let's suppose C has a value of C. Already it starts with cat. So cat minus A, which is the ASCII value is 97. So it's gonna be C is 99 minus A, which is 97. This will give us number 2. Okay, so if we want to store C, we're gonna use the index 2, which is A has a 0, B as a 1 and C as in 2. Okay, so this is quite simple. So now we're gonna check if node of children index yani ki index node of children index 2 is equal to null ptr. Definitely it's null ptr because nothing is there. So what we're gonna do is node children, which is root, index 2 has new try node. We're gonna make a new try node which gonna be C. Okay, it's quite simple. And then we will traverse the node to the children which is C and pointing to 2. Okay, and then we have a character which we gonna need to insert. Then again, now we don't need to start from root again because our node pointer is representing here. So we're gonna do is go here and insert a new node by using the same conversion and insert a here. Okay, and then we're gonna make a new node and then insert t. Okay, so once we completed our insert, as you know the for loop breaks, you can see here the node is end is equal to true. So we're gonna make this node as in true. Okay, so we have a node and which represent is true, is end is equal to true. Okay, that means it's a complete string. Okay, so if we go here and see, we are inserting a new value which is car. Okay, so now you can see how insert function works for car. Okay, so you can see now we start with again with the node which is root pointing here, and then we will make a value of C, and now it will check if node children is equal to null ptr, which is not, which is false. What it's gonna do is node is equal to node children, so it will skip and then go here, starts from here, and now it will take a next character which is ka and then search for again. Definitely this is true. This will go here, which is not sorry, it's a false because it's not null, there's a value. And then again, now it's the value is r. Okay, so now you can see node of the children is equal to null ptr, which is not. What it's gonna do is it's gonna make a new node here which is, sorry, just increase the size, and then it will store car here, and then mark is true as well. Okay, so now we have inserted cat and car here. Okay, so it just skip these two letters and then insert a new here. Okay, so what we're gonna do is now we will see what's the next. Okay, so now it's gonna insert a dog here. Same with the dog, you can see it starts from here. You can see it went to root, take a value of c minus a, which is d minus 97, and d has a value which is 0 1 2 3. 3 means 90, 97, 98, 99. So we have a c value 99, so d is 100. Okay, so 100 minus 97 is equal to 3. Okay, so now we have index 3, so now we check with the node children. So if the node children index 3 is equal to null ptr, which is a null ptr because we don't have c exist here, so we're gonna make a new node here and then insert t, and then same like we're gonna insert a new node o and g and make it true. So this is how we insert string in our try table. Okay, so now we're gonna use our next function, which is probably the searching, which is very important here. and you can see it's quite similar with the insert function but has some minor changes. Okay, because we don't make a new node here like insert, else we just put return true or return false. That's the only difference, otherwise the code is quite similar. So what we're gonna do is, and for example we're gonna search for cat. Okay, so here's a search function. We comes here in a root, we take a variable c, and then we will make an index which is c minus a, which is true index, and we're gonna go to the root to true index, which is this one, and check if it's null ptr. No, it's not null ptr. So if it's null, we're gonna put return false, else we're gonna node children and traverse to a. Okay, now it's pointing here. Now we go to check a, and then it's not null. Then we're gonna go here, and then at the end, if it's cross, if it's traversed till the end, that's mean the return node is equal to end, which is true, which we already set it on the whatever the value of this, it's gonna be true. Okay, and now if you're gonna search for cap, okay, so you can see we're gonna go here ca, but after when we search for p, it checks its ptr, it's null, because p has index has different value which is null. Right now, when start we make it null for every index, so it has a p which is null, so it will return false. That means it's not a valid string. Okay, and now we have another function which is starts with, I told you in my previous video, which is if for example if you want to search ca, it's gonna give us, it's quite similar with the search, you can see, just only difference is it's just not gonna give us the return value, instead it's give us return, you know that's the only difference, the only one line difference. So it's quite similar, insert, search, and starts with. Okay, so this is how we're gonna make a object of a try, which is, and then we will use dot insert cat car dog, and then we're gonna search for cat, search for cap, and then we're gonna search for ca and do and da. So after this both give true because we have ca do, and when we search for da it's definitely give us the error. So we're just gonna quite make it clear the screen, and then we're gonna run this code really quick and see, close without saving because we did not want to change anything, so we already implement. So what we're gonna do is, how we're gonna implement any, like run any file in C++ and Ubuntu. So first we're gonna put G++, which is the C++ compiler, and then name the file try.cpp, and then O, and then we're gonna name the file which is result. Okay, and when we enter, you see there's a executable file, and we, if you want to run any executable file, we just dot and then slash and then result. It will give us the value. Okay, so see, you're gonna see it says search cat 1, which is 1, and then search cap 0 means false because we did not have any value of cap, and then starts with ca, which give us true. 1 means true and 0 means false. Let's see, we're gonna give us the value. Okay, because we did not, we just send the exact value which is return 1 and 2. We can do the conversion here, like if dot try dot search equal to 1, let's see, it will return, it will see out false like this if we want to, otherwise it's quite simple. So this will true means 1 0, and So this is how we're going to implement the try table, try tree data structure. So it's quite simple. And first, if you understand the logic of try, you can simply, you know, um, implement this one without having any difficulty. So I hope you guys understand how try tree works. So just stay tuned with us and share, like, and subscribe our channel for more informative videos. Thank you.